Hello world, it's Craig. Okay, so today I was bringing up my MOD80, which is my 8080 based board. First, I finished up my little EPROM card that I said I was going to make. And basically, this little EPROM card, I just had a vector perf board. I put in a couple of connectors to go out to my Intel 8010B, where I can use those as either inputs to logic analyze the bus or outputs to control the bus. So I have a couple ribbon connectors for that, have my 2732 EPROM, a little bit of an address decoder for that, and then my bus connector up here. When I did this, one thing I realized that didn't dawn on me before is I have 3 or 4 different computer systems that use this 2x22 card connector on the end, and all of them have the same configuration, and that the component side, when you're looking at the component side, you have the numbered pins down here and the lettered pins are on the back. Well, so I built this just without thinking that that's the way that it was going to be. Besides, that's the way the vector says. This is the component side and that's the solder side on the other side. And then when I got it done, I realized that, well, the MIL MOD8 boards are the opposite. They have the components on the lettered side and the solder is on the numbered side. So basically what happens is when you put this in, if I've got the processor card in like that, well, now I've got my little buffer card that has to face it like that. So I thought about reversing the order of things, and I wasn't going to do that. So basically this is just something I got to live with, is remember to put this in backwards. But anyway, that said, I put that in. I wrote my favorite little program with bringing up the 8080s, and that is just this little program that simply toggles the interrupts off and on. So I have the enable interrupt and the disable interrupt, and I do that 5 times, and then I loop back to the beginning. And as I mentioned in an earlier video, the reason this is my absolute favorite little piece of code to start up an 8080 is that the interrupt enable output pin is the only pin on the 8080 that we have direct control over. And so using this little loop, I can see that as long as it's fetching instructions, and I can watch it toggle that pin and see if everything's working okay. And that's kind of my first step to do anything. So anyway, I put that in my EPROM, was running that, and if you're interested, this is just a little decoder that I used for the 2732. So the 2732 has addresses 0 through 11 on it. And then I took the memory read and I inverted that, just using a NOR gate. So I inverted that so that I could get the output enable for the chip. And then I took addresses 12 and 13. I ran those through a NOR and then inverted those so that they would give me the chip select. Okay, then I got that done. I was ready to test my 8080 board. And the first thing I did was it was completely depopulated. I put it in, hooked up the power supply, make sure that everything was going okay and the current was looking good. That completed. I populated the clock chips. So clock chips were populated, everything else was off. And then I set the clock. And setting the clock turned out to be a lot easier than I thought it was going to be. I was a bit afraid that before I really looked at the schematic that these were going to be somewhat coupled, but they're completely decoupled. So, really, if we look at what we're targeting for the clock, what we're targeting for the clock is phi 1 to be on for 150 nanosecond, then 120 nanosecond gap, and then phi 2 for 330 nanoseconds, and then a 400 nanosecond gap, and then it repeats. So the total is 1 microsecond for this. And the nice thing about the way these clocks are, if you look at the schematic, D1 and D2 are basically the first half and the second half of the full 1 microsecond period, and then the little phi 2 and the phi 1 are actually the pulse width of the clocks. So since they are decoupled, I just went and adjusted the phi 2 until the phi 1 until I got the 150 nanosecond pulse width that I liked there. Adjusted phi 2 until I got my 330 nanosecond pulse width that I wanted there, and then you can adjust D1 and D2, and those two phi 1 and phi 2s will stay the same. It's just D1 and D2 will give you the total period, and also how far delayed the phi 2 is compared to the phi 1. So you basically just adjust them until you get this like this 120 nanosecond delay between phi 1 and phi 2, and this 400 nanosecond dead time between the end, and then you'll wind up getting your 1 microsecond period. So that only took a couple of minutes to adjust all of the clock. That was working great. I went ahead and I populated the rest of the chips, checked the power. The current draw was about what I expected. I then populated my 8080. That was the last one that I populated. Popped it in, and unfortunately it didn't work. So what I was getting was it was getting the first instruction. So it was fetching. I knew this card worked okay. So it was fetching the first instruction from the bus, and then when the memory read should have been dropping on the rising edge of phi 1, I think the next phi 1 MRE should have dropped, it wasn't dropping. So the long and the short of it, and I'm somewhat ashamed, it took me several minutes to find it, if not a little longer than that. But what I had done was, when I put in this resistor, you can see this little 10K resistor right here. The pad on this end of it doesn't exist. And so at the time, I just put it in saying, okay, well, he must have meant to go to that little guy over there. I put it in thinking, okay, well, I'll come back and I'll fix that later, and then completely forgot about it. Well, as it turns out, this is the pull-up resistor on the ready line, and this wasn't 5 volts, which is where it should have been. If you look at the schematic, this was one of the minus rails. So instead of pulling this up to the 5 volts, which it should have done to give me the ready, saying that the processor was ready, it was pulling it down to this negative rail. Unfortunately, the ready line is diode protected evidently, because it wasn't allowing it to go negative. But the ready line was being pulled low, and so this was not allowing it to go past a ready, and so basically the processor just was stuck in a wait state. Okay, so I popped that guy out, looked at the schematic, realized, okay, well, the schematic says that has to go to a +5, and looked to see, found my mistake, put him back in, and this is exactly what I got. I got my clocks here, phi 1 and phi 2, and you can see this is the first instruction fetch in the sync after a reset. So I had done a reset. This is the first instruction sync after the reset. Here's my memory read, and these are my data bus up here at the top. So you can see it was getting first instruction, which is an FB. FB's enable interrupt, and pin 9 here is my interrupt signal. So you can see here's my enable interrupt, disable interrupt, enable, disable, do that 5 times, and then I have a loop that goes back to the beginning. That is good news, because now I've played with this, and as near as I can tell, with the 8080 board is working just fine. Now I'm going to go ahead and write some more code to test my input ports, output ports, my RAM. Okay, well, thanks for watching. I'll talk with you later. Bye.